Okay, so we're looking at question 7 for the 2013 exam. So we're given an LP problem with the following final tableau down here. This problem has an optimal solution at two corners of the feasible region, and we aim to find the coordinates of these corners. Okay, so firstly let's notice that in the tableau given, the Z row has no negative entries, so we can stop the simplex algorithm here to find an optimal solution at one pair of coordinates. But we can also notice that there's a zero entry in the Z row of a non-basic variable column, x1, and that means that we can complete one more pivot using x1 as an entering variable. But for the moment, let's just find the first set of coordinates where an optimal solution occurs. So we aim to find the value of x1 and x2. So x1 in this case, because it doesn't make an appearance here on the left-hand column, x1 equals 0, and x2 does make an appearance here. So we look at the right-hand side of the x2 row and see that x2 equals 2. So this corresponds to the coordinates 0, 2. So to complete this next pivot, to hopefully find another corner of the feasible region where an optimal solution occurs, we first need to find which element out of 3 and negative 2 to complete our pivot on. So how we do that, we look at the ratios 2 on 3, so we take this number and divide it by this number, and we take this number and divide it by this number, and we look at which one of these is the lowest non-negative ratio. Now, as this one is a negative ratio, the ratio we're after is 2 on 3, and that means that we have to pivot on the element 3. So that means that x2 will be the departing variable when we complete this pivot. Okay, so let's draw up a table quickly. Okay, so here's our table, and now because x1 is the entering variable and x2 is the departing, we can write x1 here, and s1 remains as a basic variable, and we can also quickly write in the 1s and 0s according to which variables are basic. Okay, so firstly, we can notice that this 3 has turned into a 1 here, so we have to divide this whole x2 row here by 3 to become this x1 row. So we have that this entry is 1 on 3, now this entry is 3 on 3, which is 1, and finally this entry is 2 on 3. Okay, next we notice that we have a negative 2 here that gets turned into a 0. So to make that change and to complete the entries on this row, we have to add 2 copies of this x1 row to the original s1 row. So we're adding 2 times 1 on 3 to 0, which is 2 on 3. Now we're adding 2 times 1 to 6, which is 8. And finally we're adding 2 times 2 on 3, which is 4 on 3 to 7, which is 4 on 3 plus 21 on 3, which is 25 on 3. So that's that entry here. Now finally, to get this 0 to a 0, according to the simplex algorithm, we add 0 copies of this row to this row, which gives itself. Okay, so we've completed the pivot, and we can notice again that there's no negative entries in this bottom Z row. So we can now find the coordinates of the optimal solution for this tableau. So we can see that x1 makes an appearance here, and it's equal to 2 on 3. And x2 does not make an appearance on that left-hand column, so it equals 0. And the corresponding coordinates are 2 on 3 and 0. Okay, so finally, to write this out formally, we have an optimal solution of z equals 9 at the coordinates 0, 2, and 2 on 3, 0. And that's it.